Synthetic division. It's not about androids, nor is it any sort of fake math. Synthetic division is a shortcut that does polynomial division for us if you're dividing by a linear factor. And that's a big if. Here are some examples of some linear factors to see whether or not you can use synthetic division. And one of the things about synthetic division is it's rarely used to find an actual quotient. It's more commonly used to confirm that a factor or a root really is a factor or a root, which you can do just about as quickly with Wolfram Alpha or a graphing utility. Some say it's just another application of Raffini's rule or the reverse area method. And some purists think it shouldn't be taught at all, which I obviously don't agree with, or else I wouldn't be sharing this with you. As to why it's called synthetic division, I'm guessing because it's kind of a fakey looking way to get to a very real answer. But ultimately the deal is, under the right conditions, it is an undeniably fast way to find a quotient or to confirm a factor. Let's see it. In regular long polynomial division, we write everything out in its place. We multiply down, carry, subtract, and ultimately find our quotient. For synthetic division, we confirm we can actually do it. The divisor has to be a linear term with no leading coefficient. Put everything exactly where it goes, including any missing terms. Then we wave our mathemagical wand and the answer pops out. Let's see an example with actual explanation this time. So how does this work? Let's synthetically divide. The first thing we do is check and make sure we can. X minus 5 has nothing in front of the x, and it's an integer term over here. That's dividable by synthetic division, so that's good. The next thing we do is we write this out as a synthetic division problem. First, here in the divisor, x minus 5. We're going to take that integer value, negative 5. We're going to change its sign from negative 5 to positive 5, and we're going to write it over here in a little balcony on the left. Next, we're going to take the dividend, the thing we're dividing from, and we're going to write its numbers down here on that same line as the 5. But we're not going to mess with the variables, just the coefficients. The reason we can get away with that is because everything is in its place. So we're just going to scaffold it all out together. The 3 in front of x cubed goes first. The negative 19 in front of x squared goes second. The 21 in front of x goes next. And the negative 46, which is the x to the 0 character term, goes last. There's our divisor and the thing we're dividing from, the dividend. Next, for synthetic division, we're going to draw a great big long bar with a space between the first numbers and the bar. That gives us room to work in. And here's how the process works, step by step. The first term from the dividend, the 3, that gets dropped straight down, written on the line below. 3 plus nothing gives us 3. Next, we take what's down here below and we multiply it times what's up in the balcony. 3 times 5 makes 15. And we put that result in the next column. Now remember, in division we would subtract, but because we changed the sign, we're going to add. Negative 19 plus 15 makes a total of negative 4. So we did 2 steps there, taking what was down below, multiplying it times the balcony and putting it over here, then adding. We're going to repeat that pair of steps all the way out through the rest of the problem. Negative 4 is going to multiply times the balcony, 5, and make negative 20. We'll add 21 and negative 20 to make a total of 1. 1 times 5 makes a total of 5. And we'll add these two together to get negative 41. There's our result. Now it may be a little hard to see what's here, so let me parse it out for you. The last number is always going to be the remainder, even if it's 0, meaning you have no remainder. In our case, we have a remainder of negative 41. The remaining numbers are the coefficients of the quotient result in increasing order from right to left of their degree. So what we have, writing it backwards just for clarity, is plus 1 is the final term. Negative 4x is the middle term. And 3x squared is the first term. all of these with a remainder of negative 41 over the original divisor, x minus 5. There's your result. There's your quotient. When you take 3x cubed minus 19x squared plus 21x minus 46 and divide it by x minus 5, the result is 3x squared minus 4x plus 1 with a remainder of negative 41 over x minus 5. So here it is again. We're going to do it a little faster, and this time there's a specific problem we have to solve before we can do it. First, can you do synthetic division with nothing in front of the x and an integer value over here? Yes, we can. We'll take that divisor, plus 3, and we'll change its sign to put it over here in the balcony and turn it into negative 3. And then we'll take these coefficient values and write them on the line. There is no x cubed term. There is no x squared term. We can't just ignore them. They have places in the synthetic division problem. So we have to write that there was a 0 in front of the x cubed, that there was a 0 in front of the x squared. And now we're ready for the x term, negative 5. And then we're ready for the constant term, 10. This is what we're synthetically dividing, with the big bar down beneath and a little room to work. To help you remember the synthetic division process, I've heard people describe the next steps as drop the baby, ma, ma, ma. Let me explain. The first step in synthetic division is take the first coefficient and drop it all the way to the bottom without doing anything to it. The ma in ma, ma, ma would stand for multiply and add. We'll take this 1, multiply it times the balcony, and put it in the next column. 1 times negative 3 is negative 3. And add. 0 plus negative 3 is negative 3. Ma again. Multiply negative 3 times negative 3 and get 9. And add. Multiply. Add. Multiply. Add. And there's your answer. 106 is the remainder. The remaining numbers are the coefficients of the resulting quotient. I often like to write these from the back because it avoids confusion. 106 over x plus 3 is the remainder. Negative 32 is the constant term. 9 is what goes in front of the x. Negative 3 is what goes in front of the x squared. And 1 is what goes in front of the x cubed. The quotient of this problem is x cubed minus 3x squared plus 9x minus 32 with a remainder of 106 over x plus 3. You may recall I mentioned synthetic division actually isn't often used for straight up division. It's more often used to check to see whether or not something is a factor. Is x plus 3 a factor of x to the fourth minus 5x plus 10? Well, if it was, it would have divided evenly. There wouldn't have been a remainder. So we know x plus 3 is not a clean factor of x to the fourth minus 5x plus 10. So let's try it one more time. And this time I'm going to ask a slightly different question. Although I am going to wind up with the quotient. The question I'm asking now is, this big polynomial has factors. Is x minus 6 one of its factors? One of the binomials that could be multiplied together to make this polynomial? Let's test it using synthetic division. Step 1, can you use synthetic division? The divisor has nothing in front of the x and an integer value over here, so yes, I can. That divisor, x minus 6, turns that number positive to go over here into the balcony. The coefficients of the big polynomial get written next. 1x to the fourth, negative 3x cubed, negative 28x squared, 59x, and 6. Every coefficient is there. Everyone is in its place. And with the big bar, we're ready for the synthetic division dance. Drop the baby. Ma. 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 And we've answered the question. Is x minus 6 a factor of x to the fourth minus 3x cubed minus 28x squared plus 59x plus 6? Yes. Yes, it is. Because the remainder is 0. It divided evenly. X minus 6 is a factor. And if that's all I wanted to know, I'm done. If I'm interested in the actual quotient, it's right here. No remainder. Constant term of 1. Negative 10x. Positive 3x squared. Positive 1x cubed. Done. The quotient of this division problem is x cubed plus 3x squared minus 10x minus 1. But if all I was interested in was whether this is a factor, I didn't need that. I know it is. And there you have it, my friends. Synthetic division is a shortcut method of doing polynomial division. It's also a great, fast way to check for factors or check for roots. You do synthetic division by writing the problem in a very specific structure with the divisor with its sign changed in a balcony on the left, the coefficients of each of the terms of the dividend across the top. Drop the first term, multiply against the balcony, put in the next column, and add. Multiply, put in the next column, add. Multiply, put in the next column, add. What comes across the bottom is the remainder on the right side and the terms of your quotient along the bottom. I hope you'll find this tool useful and fast to do polynomial division. Thanks for watching.